So 11.55 volts. So I can come back to my chart. Volts there. It means that we have the same value here at R6. We're also going to have 11.55 volts there. Okay? Now we can start working in this area. So we determined that we had 18 ohms, and we also have 0.385 amps here, so I could figure out the voltage, E2345. So I'll write that down. E2345 is equal to I2345 times R2345. So it'll be 0.385 amps times 18 ohms. So let me clear that. 0.385 times 18. And that's going to be, what, 6.93? 6.93, volts. Okay. Now what you should be able to do to double check yourself, you should be able to take your 11.55, your 6.93, and your 11.55 added together, and it should be relatively close to your 30 volts supplied. Any difference is going to come from rounding. So we said we have 11.55, 6.93, 11.55. So let's try that out just to see if we're on the right track. We already have the 6.93 in there, so we'll say plus 11.55 plus 11.55. 11.55. And it's coming in at 30.03, which is damn close to what it's supposed to be. So I could say we're on the right track. All right. So we know we have 6.93, probably closer to 6.9, I suppose. So I'm going to take, and I might just leave it. I might just go ahead and round that to 6.9, and that would give us, take us right on the money. So we'll say this is 6.9 volts. All right. So now I can take this 6.9 volts, and since this is representing a parallel up here, that means I've got 6.9 volts here, and I've got 6.9 volts here. Being the R3 is complete, we can take 6.9 and put it up in our chart. So we come over here to E3, 6.9. Now we could solve for current at that location right there. So, I3 would be equal to E3 divided by R3, which would be 6.9 divided by 30. 6.9 divided by 30, 0.23 amps. Okay, so I'm going to put that on our chart over here. Okay. Now, since this represents a parallel portion up here, that means I'm going to have 0.23 amps at both of these locations. So we got 0.23 amps here at R2. I could write that in. since that's a complete number there. And I can also solve for voltage there. Let's go ahead and do that. So I've got E2 is equal to I2 times R2, 0.23 times 30. And it's going to be ohms. I'm going to take that times 30. And that is 6.9. Is that right?
I'm getting, oh, shit. Oops. Well, I just made a mistake. Because that is, and I apologize.
45 ohms up there, so I got screwed up. Don't worry, I'll do it real quick. Oh yeah, that's what I did right there. So I skipped a step. Let me rectify this real quick. Okay. Zero here. What I needed to do was find my current I2, 4, 5 right here. So I need to take that 6.9 volts divided by 45 ohms, right? Jack that up. So it's going to be E2, 4, 5 divided by R2, 4 and 5. So that's going to be 6.9 volts divided by 45 ohms. And I've got 0.153. I'm just going to call it 0.15. So, where I've got this should be 0.15 amps right there. Okay, sorry about that. Now we're back on track. So, E2 is going to be equal to I2 times R2. So it's 0.15 times 30. So we'll clear that. 0.15 times 30. And that's 4.5 volts. And that makes more sense. All right, so now I can come over here and write in my 4.5. And I've solved 1, 2, 3, and 6. I only have 2 more to go. Okay, now I also have, I had 0.15 amps here. I'm also going to have 0.15 on this combo. So, and being that this represents parallel above, I'm going to have to figure out what the voltage is. So I'm going to have to figure out E45, because I already know I've got 0.15 amps. Okay, so E45 equal to I45 times R45. So 0.15 times 15 ohms. So 0.15 times 15 is going to be 2.25. Okay, so that means I've got, since this is a parallel, I've got 2.25 on both of these. So now I could write this in. And now I've got my two items I need to solve for that current right there. So I could take, and I'll just use, it doesn't matter since they're the same value, so I'll just take 2.25 divided by 30 for I4. I4 is equal to E4 divided by R4, which is 2.25 divided by 30 ohms. Sorry, I stretched my back out. So 2.25 divided by 30 ohms, and I got
0.0.
0.75 amps, which should make sense. That means I've got 0.075 here and 0.075 here, which is,
So we had 0.15 coming in, so we're going to have exactly half of that on both of these, right? So 0.075 plus 0.075 be 0.15. So it comes in and it splits up equally, then it comes back together here. I've got 0.385 coming in, and it splits off from R1. I'm going to have, basically, if I take R2 and R3 added together, it should equal roughly what R1 is, so we can double check that. So these two added together, 0.15 plus 0.23, and mind you, there is a little bit of rounding going on. So 0.15 plus 0.23 equals 0.38. So once again, very close to that. My voltages come in. We already did that where we had our 11.55 or 6.9, 11.55 did equal 30. Now, we can do something similar to that also. We should have these two voltages should equal our 0.69. So we have R2, which was 4.5, and then we had our R45 voltage at 2.25, so 4.5 plus 2.25 would be what, 6.75. So once again, just a little bit of a rounding issue, but it's really close. So anyways, the chart can help you out. The trick is to get this guy redrawn. So I like to do this birthday cake, whatever kind of method you want to call it, where I take each loop. Let's see if I can quit from shaking.
I take the inside loop and make it turn into a straight line. Then I take my next loop, and that becomes the next part. And I take the last loop, and it ends up being right there. And then it's just a matter of solving, then reducing those two, then reducing that. And we've got those three series, so it ends up being this guy right here. Then you take your unknown value, which in this case is our total current, brought our current up to 0.385, figured out our 3 voltage drop, took this voltage up since that was represented a parallel, took our 6.9 up, used 6.9 divided by the 2 resistance values to come up with our 2 currents, which were 0.23 and 0.15. Since this represented a series, we took 0.15 up here. And here, we figured our two voltages, which were 4.5 volts there and 2.25 volts here. That was analyzed. Then we took our 2.55 volts, or excuse me, 2.25 volts, since this represents a parallel up here. Brought that up, and we figured our final two currents, which were 0.075 each. Hopefully that answers your question on this. And if you have any more questions, let me know. This is a longer video than I thought. Good luck, man.